Your homework for tonight is going to be to finish this note sheet. We will do 3 problems together, and the expectation is you will do your best to complete the remaining problems on your own, but obviously check the key if you do need some feedback as you work, but also at the end when you're finished, just check to make sure you have the correct understandings. So to start off, we're going to look at graphing exponential functions. Now, for this first problem, you're given a table and it says y equals 2 to the x is the function we are going to evaluate. Well, very nicely, we just talked about exponents and how to deal with negative exponents, zero exponents, and positive exponents. So think about if I subbed in a negative 2 for x, my y value would be 2 to the negative second power, which is really the same thing as 1 over 2 squared, or 1/4. So if I were to graph this point, I would go to negative 2, and then 1/4 would be an extremely small value, approximately there. Now, if we did the same thing with negative 1, we would get 2 to the negative first power, or 1 over 2 to the first power, which is equivalent to 1/2. So we could graph that point, negative 1, positive 1/2. Now, if we sub in a 0, you should remember that anything raised to the 0 power equals 1. So we can graph the ordered pair 0, 1. And then we can sub in a 1 to get the value of 2. Then we can sub in a 2 to get the value of 4. And then finally we can sub in the value of 3 to get an 8. Now, when you connect these points, you will see the makings of an exponential function, where one end of the function increases without bound, and the other end will decrease and approach a value that we call a horizontal asymptote, which you have already learned about with rational functions. So if you think about it, if we were to continue to sub in negative values for x, we would see that the y value would keep getting smaller and smaller and smaller. For example, negative 5 in x would give us 2 to the negative fifth power, or 1 over 2 to the fifth power, which never becomes negative. It actually just becomes extremely small and closer to 0. Now, we call the base of the exponent this number right here, and we call that the b value. Notice in this case, the b value is 2. And as you can see from the graph, this is a growth function. We keep multiplying by powers of 2. This will grow left to right. The y-intercept of our graph is 0, 1. And that horizontal asymptote, as I discussed, is where this flattening out of the graph happens, which we saw to happen at y equals 0. Now, for all exponential functions, the domain is negative infinity to infinity, and the range is dependent on that horizontal asymptote. Notice we are always above that horizontal asymptote, so our range would be from 0 to infinity. Now, to the right of this graph, we're looking at a very similar function, but this time we're looking at 1/2 to the x power. So I am going to do the same thing I did with the first function and start by subbing in, let's try that again, 1/2 to the negative third power. Now, if you guys remember, the negative is going to flip this number inside, so I'm actually going to get 2 to the third power, or 8. This time, a negative 3 gives me that value of 8, when over here we saw it happen with a positive 3. So I can graph that first ordered pair, negative 3, positive 8. Now we can continue going and sub in a negative 2. And again, that negative is going to flip that number inside and make this 2 squared. So we get negative 2, positive 4. All right, my children are screaming in the background. Pretend like you don't hear that. 1/2 to the negative first power. You're going to apply this negative to what's inside, and you're going to get a 2 to the first power, or just 2. Now, for the 0 exponent, same thing we saw as before. 1/2 to the 0 power gives us a value of 1. So when we go to 0, we're graphing 1. And then we can do that same thing, 1/2 to the first power. We get 1/2. Notice this is where it's becoming small now. And then for that final point, we can sub in a 2. Well, remember when you square a half, it equals a fourth. Now we can connect the points as we did with the other problem. And you will see a lot of similarities, but then also some differences. This time the base of our function was 1/2. And we are seeing that this is actually decreasing left to right, therefore showing us decay. The y-intercept of this graph is also 1, and the horizontal asymptote is also at 0. The domain is -infinity to infinity again. No restrictions on x. We can sub in any number, as you saw, but the range is restricted. We are always above that asymptote. So these are two parent functions of exponential functions. And you'll see if you read through this, the what did you find part, that an equation in this form, where b is greater than 0 and b cannot equal 1, is what we call an exponential function. And that's what we'll be studying today. Now, we talk about exponential growth when that b value is greater than 1, and decay when it's between 0 and 1. And then again, this idea of this asymptote, a horizontal one, occurring at the line y equals 0.